In this video, we're going to introduce the basic rules of differentiation. Alright, there are four types of, there are certain rules that differentiation you need to master these techniques. So which is, the first one will be the basic rules, the product rules, and the quotient rules. And of course the chain rule, right? So this is all you learn during your secondary school. So for example, if you have a function, so I'm talking about the formula. So let's say you have a constant, right? So if you differentiate the constant, you differentiate, or you can set this one to be a, let's say this is also a y, you can just write this to be dy dx, right? dy dx, so will be f prime x, so will be, you differentiate c, you are getting a constant, right? You're getting a constant. You can prove this by using first principle. So now, so there is a, okay, this is the basic rules that we're going to learn. Let's say you have y equals to x to the power of n, right? X to the power of n. So to differentiate x power of n, where n is a power, so you have to bring down the power, and the x and the n you subtract by 1, right? So this is another basic rule. So for example, 3. So if you have, let's say y equals to kx power of n, it's the same thing. So dy dx, differentiate. So you bring down the n, multiply with the kx, and the n you subtract with 1, right? The n you subtract with 1. So this is the basic rules, right? The basic differentiation rule. So now in this video, I'm going to talk about certain examples for the rules of differentiation. Alright, let's look at this example here. So let's say you want to find dy dx for this case. Differentiate this y with respect to x. So very simple, you just apply this rule, right? So very simple, you have 5 times 2. You just bring down the power, 5 times with 2, you have 10, right? And the x, and the power for 5, you reduce by 1. So it's become 5 minus 1. So you have 4. Minus with 2, multiply with 3. 2, you bring it forward. So you multiply with 3, you have 6. And x, the 2, you minus 1. So you have power of 1, right? So plus with, differentiate x to the power of 0. So x to the power of 1 will be 1 multiplied with x, 1 minus 1. So you have 1 x power of 0, which is 1. Or you're already very familiar, this is actually 1. Differentiate a constant, you are getting 0, right? If you differentiate a constant, you are getting 0. So this is a differential form of this function. Alright, so let's look at the second example. Alright, let's look at this example 2 here. Example 2 here. So this is also a function. The y, you can apply basic rule here. So we can rewrite this thing. Before you differentiate, make sure you rewrite, because this x power of 3 is on the denominator. You can write as x to the power of negative 3, right? X to the power of negative 3, followed by 3x power of 4. This one also, x power of 2. You can rewrite as x to the power of negative 2. Right? This is before you differentiate. Right? So now you're starting to differentiate. It will be easier if you already modify. So then the negative 3, according to this rule, you bring forward. So you have negative 3 over 4. Negative 3 multiply 1 over 4. So then x, negative 3, you have to minus 1. Right? You have to minus 1. So plus with 4 times 3, 12. X to the power of 3. 4 minus 1 is 3. Negative 5. Negative 2 bring forward. You are getting negative 2 times with negative 5. Negative 2 times with negative 5, you have positive 10. Right? Positive 10. And x, the negative 2, you minus 1. Right? You have negative 3. Alright? You have negative 3. And this one you have negative 4. Right? You have negative 4. So overall, your dy dx, is negative 3 over 4. And I rewrite this one. It's nice if you write in positive form. So you bring it down, x to the power of 4, right? So plus with 12x to the power of 3, plus with 10 over with x to the power of 3, right? As you bring up, you're getting negative 3. So this is the second example for you. I will go for more example, and you can assume this example as your practice. Before you view the video, you try first and you see the video. Alright, continue with this third example. So it's also an example that I want to know how to apply the basic rule. So for this case, you see there are on top and right, there are numerator and denominator. Some will say, oh sir, I want to apply quotient rule. But this is a simple case here because there is only one term on the denominator. So if possible, you choose to simplify before you differentiate. Yes, you can apply quotient rule if you want, but it's better for you to simplify first. I try to avoid quotient rule for these cases here. So it means you can divide each of the term by square root of x to the power of 3 over 2 over with square root of x, because there's only one term on the denominator, right? So you simplify by using the concept of index. So as you know that 3x, this is power 1, right? You know that square root of x is x to the power 1 over 2, right? Square root of x is x to the power 1 over 2. So is x to the power 1 over 2 here. So you have to take 1 minus with 1 over 2, right? Divide, divide. So this is exactly the same thing. You're getting 1, right? You're getting 1. And for this one also the same. So x power 3 over 2, because you divide by x to the power 1 over 2, right? 1 over 2. So it means that you need to minus with 1 over 2 as you divide x to the power 1 over 2. So then you further simplify before you differentiate. So you have 3x, 1 minus 1 over 2. So you have 1 over 2 plus constant 1, right? Plus with x, right? X. 3 over 2 minus 1 over 2. 3 minus 1, 2. 2 over 2, you have 1, right? Finally, you have simplified. Right? You simplify first. So some cases you need to simplify before you differentiate. For the differentiate, if this is fx, I can write as f prime x, which is the differentiate this function, the first derivative of this function. So you bring down the 1 over 2, multiply with 3, right? 1 over 2 multiply with 3, and the x, the power of 1 over 2, you have to minus 1, right? The 1 over 2, you have to minus 1. And you differentiate a constant. Based on this rule, differentiate a constant, you're getting 0, right? You're getting 0. And you differentiate x, you're getting 1. So then finally, you simplify, you are getting 3 over 2. 3 over 2. As this one, you are getting negative 1 over 2. Negative 1 over 2. X to the power of negative 1 over 2. Can rewrite as 1 over x to the power 1 over 2, which is 1 over square root of x, right? So then you have square root of x here. This one 0. So you differentiate x, you're getting 1. So this will be your answer for this question here. Alright, as simple as that. So I go for many examples in this video so you understand the basic rule. So if you're Form 5, you already forget what is the basic rule. So this is all the example that you should know. Alright, this is the fourth example. So I think this is the last answer, good enough for you to understand the basic rules. Alright, later I will still teaching you the basic rules. So for this case, there is a square here, right? So you cannot differentiate what is inside here. This is a composite function. So it means in the power, right? In the power. So, but this is just a square, right? It's just a square. But if this is a cube, this is a power of 4, power of 5, then it will be better not encouraged to using basic rule, because you need to expand by using binomial. They are so tedious, right? So that's why we have to introduce another formula later, right? Chain rule and power rule, right? So look at this. So you have to expand, right? So it's encouraged you to expand. So 2 over square root of x. So or you can apply the formula for a square minus b square plus a square plus 2ab plus b square. Alright, it will be faster. So before that, you have to expand first before you differentiate. This is, you have power, right? You cannot differentiate inside if there is a power. So now you have expand. So square root of x, square root of x. You know that square root of x multiplied with square root of x, you are getting x. So you have x as a first term. So followed by this one. So you have square root of x multiplied with 2 square root of x. Negative here, right? Positive, negative. So you have negative, right? You are getting negative, and this square root of x will cancel off. So you're getting negative 2, right? You're getting negative 2. And this is also the same. So as you multiply, this one will cancel off. You're getting negative 2, right? You're getting, cancel out, you're getting negative 2, right? So now followed by negative, negative, positive, right? So 2 square root of x multiply 2 square root of x. So you are getting 2 times 2, 2 times 2, you have 4. 4 over x, right? 4 over x. So 2 times 2, 4. Square x, right? You're getting x. So it means you have 4 over x here. So then later you are getting y. After you simplify, you from x plus with 4 over x, negative 2, negative 2, negative 4. So this is the simplified form. Alright, now you have no power here. So you can differentiate by using basic rule. Alright, you can differentiate by using basic rule. So dy dx. Dy dx. So you will have differentiate x. Okay, I can rewrite this thing to be x plus with 4x power of negative 1. X plus with 4x to the power of negative 1 minus with 4, right? So that easy for me to differentiate. Differentiate x, you are getting 1, right? Differentiate positive 4x power negative 1. Negative 1 times 4, you have negative 4x. Negative 1 minus 1 again, you have negative 2. Differentiate constant, 0. So you're having your dy dx to be 4 over x to the power of 2, right? So this will be your answer for this question. So that's all example for the example for basic rule of differentiation. So later we're going to discuss about the power rule, the composite function, alright, the chain rule.